How are you people doing? Welcome to today's session. I hope that all of you guys are doing good. My name is Anoop and this here is Vedantu 9th and 10th English channel. And yes, I have no idea how to play a guitar and I'm still holding one because people, the topic that we're going to talk about today has got something to do with beautiful instrument that I have in my hand right now. Okay, so let me ask you this question. If you've ever seen a guitar before, you've probably seen there's this big hole right there in the middle. Why do you have one? And why is the guitar made up of wood? Why is it so? Why does it have to be such hollow structure? Why couldn't it be just the strings? Because that is the one that is producing the sound ultimately. Why do you have this? Let's answer that question today. Okay, let me ask you a couple of more questions, alright? It's not done. Okay, when you talk about a radio, have you ever wondered why do you have to adjust the frequency of a radio only to a certain value? Only then we can hear the sound. Like for example, if you've ever heard about radio indigo and all that, you have to go to the 104.2 whatever. I don't know it. I don't know what the value is, but you have to tune it according to that so you can hear the sound. Why is that so? Okay, how does a sarangi work? Have you wondered? Okay, what about a glass? You know, if you've ever seen an opera singer go ee and they break the glass, that is the worst opera sound there is, but still, you get the point. When they go like that, why does it break? Why does the glass break? What is the reason behind it? Yeah, we're going to answer all of these questions in today's session, so very warm welcome. And the topic for today, people, is going to be resonance. What exactly is resonance? Everything that you need to know about resonance today, you're going to learn that and you're going to walk away with the best of the best knowledge there is. Go shine outside the world, people. Go shine out there. So yeah, people, this is going to be the fourth session of this chapter. Sound welcome one and all. So people, today we'll be talking about resonance. Now before I get into resonance, let me tell you something very important. Now in the last session, I had told you that every object has its own natural frequency, right? Every object has its own natural frequency. Now, when an opera singer starts singing, what is happening is that the opera singer, he or she, they're producing the sound which basically vibrates the air molecules around their mouth. So now imagine that the person is standing over here and going ee. Get the point, right? They go ee. Now this is basically because of their voice, because of their continuous voice, the continuous strain that they're putting into their voice. There is some force being applied on this glass. You can't disagree with me. There is a force being applied on that glass, which we'll call it as a forced vibration. We'll call it as a forced vibration, right? Now, this forced vibration will have its own frequency. We'll call it as FF, the forced frequency, or the frequency of the forced vibration. Frequency of the forced vibration, because obviously every object has its own frequency. So here also, because of the sound waves, it has its own frequency. And this object, the glass, also has its own natural frequency. Now listen carefully, guys. This is where the magic happens. When the frequency of the forced vibration, becomes equal to the natural frequency of the body, what happens is that suddenly the amplitude of the vibrating body increases. The body starts to vibrate with a greater amplitude. Look at that, guys. Look at that glass, which is a very rigid structure, suddenly starts vibrating with a greater amplitude. And what happens? Voila, it breaks. This is what is called as resonance. When the frequency of the force vibration and the force that you're applying, the force vibration should be periodic in nature. It should not be like ee and then stop and then go ee. That cannot happen. It should be like ee. Get the point? No? So, alright, so when the frequency of the force vibration becomes equal to the natural frequency of the body starts to resonate, and this is what is called as resonance. Or in other words, the amplitude of the body increases, the amplitude of the vibration increases, and this is what is called as resonance. And people, the frequency at which the body's amplitude increases, that frequency, that value of frequency is called as a resonant frequency, because obviously only if that matches then the body starts to vibrate with greater amplitude, and that frequency is what is called as resonant frequency. Now in the case of guitar, people, you are actually able to see resonance itself. Now I'll talk about it as we go ahead when we talk about uses, but this is the whole point of resonance. Now the two important things you have to remember is that in the last session I told you that you have three types of vibration: your forced, natural and damped vibration. Now this is actually a type of forced vibration, but it's a special case of forced vibration because the frequency of the forced vibration becomes equal to the natural frequency, and that does not happen every single day. When that happens, that is where you see resonance. And also people, the object is you're inducing it, you're making it to vibrate at its natural frequency, and that is what is the whole point of having resonance. Now what we're going to do right now is we're going to look at some amazing experiments, some demonstrations to actually demonstrate or to show resonance. So listen very, very carefully guys. Any of these could be asked you in exams as well, so listen very carefully. The first demonstration is in the case of a tuning fork. Now look at this experiment carefully, right? So there are two tuning fork. There's a box at the bottom that's called as the voice box, and you also have there's a little bit of gap in between. Now the person hits with the rubber gong or the rubber structure onto the first tuning fork, but then you see that the second tuning fork also starts to vibrate. Why does that happen? Now here's what happens guys. When the person hits the first tuning fork, it starts to vibrate, or it starts to it starts to vibrate with its own natural frequency. Now this will basically, that because this is vibrating, the box also will start to vibrate, and there is air particles inside the sound box, so this will also start to vibrate, this will also start to vibrate. Now the air particles will start to vibrate, the next one, the next one, the next one, and they will vibrate the air particles inside the other sound box. And because the air particles inside the second sound box, let me tell this A and this is 2. So what happens is the air particles inside the second sound box starts to vibrate. This also starts to vibrate. The sound box also starts to vibrate. And that basically, the vibration of all of this would be equal to the natural frequency of the body, or the force vibration is equal to the natural frequency of the body. And because of this, what happens is that this particular tuning fork also start to resonate. It also starts to vibrate with that frequency at which the tuning fork A was vibrating, alright, the same frequency as tuning fork A was vibrating. Now here's the thing. Every tuning fork has its own frequency, has its own natural frequency. Now look carefully at the GIF people. When they change the tuning fork to something that is more bigger, you don't see that vibration, because only if the frequency of both the tuning forks are matching, only then will this happen. Because this is you can call that as the forced vibration, which has its own frequency, and the frequency of that force vibration, when it becomes equal to the natural frequency of the second tuning fork, that is when you see the vibration happening, and the amplitude of the vibration on B would be much more greater. But obviously it's a tuning fork, you can't really see because it vibrates really, really fast. It oscillates really, really fast. But yes people, if you change the tuning fork and put another one with a different frequency, then it would not happen, because the frequency of the force vibration and the natural frequency should be equal. And that is one case that you can never ignore. Now all your notes can be downloaded, so don't worry about people, everything can be gotten at the description below. Now the second observation we're going to talk about is something that you see in a pendulum. Now look at this people. Let me name this as A, B, C, D and E. Look at the lengths of the pendulum. All of them have different lengths except for D. If you look carefully, A and D have the same length. So that means the frequency of A and D will be equal. The natural frequency of A and the natural frequency of D is going to be equal. Now I am only oscillating the first pendulum, and I'm not touching anything else. So what happens when it starts to oscillate, when it starts to vibrate? What happens? The force vibration would basically pass through the string, would apply a force over here, would apply a force over here, would apply a force over here, will also apply a force on this as well. Now all of them are vibrating, but if you look at the GIF very, very carefully, you can see after some time A and D will start to oscillate with the same, they'll start to oscillate in the same sync. All the others are vibrating to a little extent, but D, on the other hand, would be the one which will be oscillating with the maximum amplitude, and it will be in sync with A. Why? Because their frequencies are equal. So this is the forced vibration. This already has a natural vibration. So what happens is that it has a natural frequency. So when the frequency of the forced vibration is equal to the natural frequency of the pendulum, what happens is that they both start to oscillate in sync. So that is what you notice over here. Now all the others are also oscillating, but at a very small amplitude. The displacement is not that great. But in C, however, okay, I think, yeah, okay, I think I named it different. No, it is D itself. So D in this case, you can see that it vibrates, it oscillates a lot more because the frequency of A and D is equal. Simple. So that is the answer, guys. That is why, that is another demonstration of this one. Moving on to the third demonstration that you see of resonance is resonance in air column. So all you have to do is take a tuning fork and take a tube like this. Basically this is a setup. So you have filled this up with water, and you've connected it with a rubber tube. Both of them are connected, and what you do is basically bring the tuning fork near the mouth of the test tube A, and you see that when it starts to vibrate, the air particles will also start to vibrate at its own natural frequency, and the water particles will also start to vibrate with its natural frequency. And then what happens is suddenly you'll be able to hear a loud sound from here. Why do you hear that sound? Because all the water particles and the air particles will start to vibrate with its own natural frequency because of the tuning fork, because the frequency of the tuning fork, the force vibration, the frequency of the force vibration will be equal to the natural frequency. And then what happens is suddenly the amplitude of the sound increases, and then puff, you're able to hear a new crazy sound. Right, people? So this is the third demonstration of the same. Now to talk about some of the examples of resonance, guys. Examples of resonance though is amazing. Starting from guitar to a lot of things that you see around you. You can actually experience resonance every single day. Let me come to each one of those examples. Starting with a simple pendulum. So what you have is this basically two different pendulums of the same length. So natural frequency of both of them are the same. Frequency of both A and B are the same. You see this? This starts to oscillate. This will create a force on this one, and because the frequency of the force vibration is equal to the natural frequency of the second pendulum, that is the red pendulum, that starts to oscillate. And when it loses the energy, this will again create a force on this one, and basically that will also start to oscillate, and they both start to oscillate in sync. See that one stops, the other one starts to oscillate. When the other one stops, the other one starts to oscillate, because the frequency of both the pendulums are equal. Simple. Another example is nothing but resonance in machine parts, especially in the old vehicles, because these days all vehicles are so well damped in the sense you have better suspension and everything, so all the resonance is damped. But in the case of old vehicles and all that, old buses, old cars and all that, you can actually experience this resonance. So when the motor starts to vibrate at that high frequency, and when it matches with the frequency of the entire bus or with the entire car, you can see the amplitude suddenly increases, and you start to feel that discomfort suddenly goes like that. Why? Because of resonance again, because the frequency of the engine at which it's vibrating and the natural frequency of the body becomes equal, and the amplitude increases, and it becomes really uncomfortable for you to travel in those kind of buses. Especially I still remember certain buses when I was going to school. These days I think those buses are decommissioned, but yeah, when I was going to school, you could actually experience that these really old BMTC buses, which looks like a box, actually had this very bad vibration, and you start to feel that irritation, because the frequency of the motor at which it's vibrating and the body and the entire bus starts to it starts to vibrate at the same natural frequency. The frequency of the force vibration becomes equal to the natural frequency, and the amplitude increases, and it vibrates like crazy. Sometimes even glass also breaks because of that. In the case of string also, you can actually experience that. So you see this over here, when the frequency of this thing, the vibrating body becomes equal to the natural frequency of the string, it starts to, the frequency of the amplitude of the vibration increases. You can see that it increases suddenly. This is also another example of resonance. Apart from that, you can see that in the case of stretched string, you can see that in the case of musical instruments, like in the case of guitar and all that. So here what happens is, these people, that the string starts to vibrate. The string will start to vibrate the air particles below. So what happens is the air particles inside that box that is there, like I just told you, the box start to amplify that sound because it matches the string, the vibration of the string matches the natural frequency of the air particles, and suddenly the sound is amplified and you're able to hear the sound of the guitar more clearly. Now the best example is, people, take a rubber band. Now rubber also, if you stretch it, it looks like a string. Now if you ring that, do you hear that sound as loud as a guitar sound? No, you do not, because the box that is there will amplify the sound. In the case of speakers also you can experience this. In the case of the tuning fork, we've seen that. In the case of bridges also, I don't know if you guys know this, you are not allowed to march past on bridges because of this, because when you're doing march past or when you're doing everything in sync, so when you're doing march past, everyone goes that, they're all going in sync. Right, everyone lifts their right leg, left, right, they go like that, right? So what happens is sometimes the frequency of that vibration could also become equal to the natural frequency of the bridge, and it starts to oscillate, and that could bring the whole bridge down. There was another incident that happened in the past as well. In the 1900s, we've actually seen one of that, the Tacoma Bridge. You can actually see that online. The name is Tacoma Bridge. So you can actually see that the air particles actually started to vibrate, or the frequency of the force vibration became equal to the natural frequency of the bridge, and it basically broke. But apart from that, it's not just resonance. There is also something called as aeroelastic fluttering. That is also one of the reasons why it broke. It's not just resonance. So if you look into it, you'll be able to get a lot of information on that. It's called as Tacoma Bridge. You can check it up online. You'll be able to find lots of information on that as well. In the case of radio, people, even in the case of radios and TV also, you are able to see resonance. I don't know if you guys know this. See, people, the radio signals and all are transmitted from some corner, right? Imagine there's some radio station in the corner of some corner of Bangalore or whatever city you're in. It's not like it's right next to your house. It's like it's far away, but you can still hear it. Why? Because they are transmitting radio signals, and it has its own frequency, and that frequency, when it matches the frequency of the radio device, what happens is it starts to resonate and you are able to hear the sound. Now this frequency could be different for different radio stations. Like I told you, it can be 97.2 or 96.5, whatever it is. That is the frequency at which they are, they are sending out the radio waves. So if your device matches that frequency, it starts to resonate and you are able to hear the sound. Done. In the case of TV also, it's the same thing. So all of these are where you see resonance. A wonderful concept in physics where you're talking about resonance. Now though you'll be studying about this in your 11th and 12th grade as well, guys. So make your basics strong about resonance, because this is something that is not going to leave you soon. So make sure that you clear the concept as well. So this is the difference between force vibration and resonant vibration. For all of those who are still confused about this, force vibration and resonant vibration, what are the difference between them? First of all, in the case of force vibration, people, the external force is periodic, but it is not equal to the natural frequency of the body. Here it is periodic and it is exactly equal to the natural frequency of the body, and that is why you see the resonance. Otherwise, you can't. Why would you call it as resonance, right? It's same as the natural frequency, and that is why you see the amplitude increasing. Here the amplitude is small, but here the amplitude becomes large. As it becomes equal, it starts to vibrate with greater amplitude. Here it's not exactly in phase. The external vibration and the natural frequency of the body is not exactly in phase. Here the vibration is exactly in phase. That is why the amplitude increases. And here it does not last for a long amount of time, because obviously there's a lot of loss happening because of friction and all that. But here you see that the vibration lasts even for a longer time. Even after you stop, once a resonance starts happening, even if you stop the external force, it will still continue to oscillate with a greater amplitude. So it lasts comparatively for a longer period of time. And by that, people, we have successfully completed what is resonance. If you want more such amazing sessions and have fun and also gain 100% knowledge and 100% mark, you can see the link that is given in the description below, and it'll also be in the pinned comment section as well, people. So let me know how was the introduction. I did my best, people. Let me know that in the comment section as well. Do not forget to like, subscribe and share the video as well. Now apart from that, people, the pro subscription course that is there, which is the link that is given in the below in the description below and on the pinned comment section, would take you to a link which would basically ask you for the grade and for what syllabus do you follow in school. Now these sessions that I'm talking about is highly interactive, and you have unlimited live classes that you can take, and more importantly guys, you'll have high level quizzes where you can test yourself, and the best part is that you can compete with the rest of the world and check where you are really at, where are you standing compared to the entire world. You can see that, and more importantly you have interactive replays, so even if you miss out a session, you don't have to worry people, because you can watch the replay and take part in the quiz and see the leaderboard as well. So you're experiencing the best of technologies that is there out there. And apart from that, you can download all the premium content without any hassle. All the notes are downloadable, and you can also download all the handwritten notes as well with in-class doubt solving with the help of the class teacher and the master teacher. And people, you also get to take out all the tests and assignments, take out all your frustrations, all your fears out, all the, all these tests and assignments, and get rid of that fear that you have of your exams and make yourself better every single day. And apart from all of these, you have 5,000 plus micro courses and crash courses, all for free if you enroll into the pro subscription course. Again, the link is given in the description below, and it's also in the comment section as well. All you have to do is that enter that link, and this is my coupon code AME Pro. Enter this coupon code to avail those amazing discounts as well that is waiting for you people in store. So again, the link is given in the description. So once you enter that link, people, this is what you're gonna get. If you go for the 1 month subscription course, the cost including the coupon code, if you enter the coupon code, will come down to 2,159, and for the 3 month subscription it'll be 5,599. Don't go for the 6 month subscription, because obviously you have only 3 months left, and this is very, very important that you utilize these 3 months. So that is the link. Again, this is the price that you'll be paying. And the thing is, people, in a duration of 1 month, you would have roughly attended about 200 sessions, and for those 200 sessions, if you're paying 2,159, roughly you'll be paying about 11 rupees per session, just 11 rupees for your own future. And if you go for the 3 month subscription, it's 5,599 is what you're paying, and you'll be taking about 600 sessions, and that is the minimum number of sessions that you'll be taking, and roughly you'll be paying about 9 rupees per session. So you're getting a lot more for a lot less. Again, the link is given in the description, and that price that you're paying is actually less than what you spend for Lace, which is basically a 20 rupees packet, right people? Link description, code AME Pro, do not forget that. So with that said, people, let's get on to some questions and test our knowledge. Now I want everyone to put down the answers of every single question in the comment section below. Pause the video, type out your answers, keep it ready, and then send it. If you want to send it one by one, that is also perfectly fine, but I want to see those answers. I want to know if you guys are really trying out the questions as well. The questions are very, very interesting. Pay attention and you'll be able to get the right answers. Here's the first question. Resonance is a special case of dash vibration. Is it a special case of natural vibration, damped vibration, forced vibration, or none of these? When you talk about resonance, it's a special case of dash type of vibration, and the answer is forced, people. Without a doubt, it's forced vibration, because like I told you, when the frequency of the forced vibration becomes equal to the natural frequency, that is when you see resonance. So obviously it's a special case of forced vibration. Second question. During resonance, the frequency of the driving force is dash natural frequency of the given body is greater than, less than, equal to, or either greater than or less than. During resonance, the frequency of the driving force, that is the force vibration, is dash natural frequency of the given body. The answer should be equal to. Both their frequency should be equal. That is when you see resonance, right? So that is the answer. Moving on to the third question. Which of the following statement is incorrect for resonant vibration? The amplitude of vibration is very large. The vibration lasts for a very short time after periodic force has ceased to act. The vibration lasts for a very long time after periodic force has ceased to act. Or both A and B are incorrect. Which of this is incorrect for resonant vibration? And the answer, people, for this question is actually option number B. It lasts for a long time. It does not last for a short period of time. That is in the case of forced vibration, because of the resistance, the air resistance. It slows down. The force gets dampened up. But in the case of resonant frequency or resonant vibration, you see that it lasts for a longer time. It doesn't last for a shorter period of time, right? So that is the answer. Moving on to the fourth question. In resonant vibration, vibrations of the body are dash with the external periodic force. Is it in phase, out of phase, either in phase or out of phase, or can't say? In the case of resonant, the vibration of the body are dash with the external periodic force, and the answer is in phase, people. They have to be in phase, no, because they all have to be equal so that resonance can happen. Last question. Resonance occurs when the frequency of the applied force is what? Exactly half the natural frequency of the vibrating body, exactly equal to the natural frequency of the vibrating body, twice the value of the natural frequency, any value greater than the natural frequency. One of the most easiest questions. Do not get this wrong. The answer is option number B, people. It's exactly equal to the natural frequency of the body. And this here is your homework. A tuning fork of frequency 259 hertz resonates with another tuning fork of frequency dash hertz. Let me know what is the answer in the comment section below. I'll be hoping to see some amazing answers for this question. Thank you for joining, people. Do not forget to like, share, and subscribe. Do not forget that. It's very important. Show us some love. Show us some empathy. Yeah, show us some for all the guitar that I played. It took a lot of practice to do that. So make sure that you like, share, and subscribe, people. And again, if you want to take part in the NTSE preparation course, these are the links you can take. You can pause the video and check out the links as well. The course price of the NTSE 2020 prep has been down, is bought down to $9.99, and if you talk about the mock test, it's just 99 rupees. You get a 90% discount on that as well. The link to join us to unravel the world of online education is given in the description below and also in the comment section as well. Check it out. Thank you for joining. See you guys in the next one. Take care of yourself. Stay safe. Peace out, people. Bye bye.